The function g of x is given by g of x is equal to 4 cosine of 2x, which of the following is an equivalent form for g of x. Now, cosine double angle actually has a couple of different forms because of the Pythagorean identities. So the base form actually we can get from cosine addition. Recall, if you recall, cosine addition is cosine alpha cosine beta minus sine alpha sine beta. Now, if the alpha and the beta are the same as they would be for a double angle, we would end up with cosine squared x minus sine squared x. Now, we have this all times 4 for our purpose here, but this doesn't look like anything that we have. The closest thing is c, but c has addition instead of subtraction, so it cannot be that. To get the other identities, we need to use the Pythagorean identity, which is sine squared plus cosine squared is equal to 1. I know that looks awful, I apologize. If we solve this for either sine or cosine, we get two different replacements we could use. Solving for sine, we get sine squared x is equal to 1 minus cosine squared x. And for solving for cosine, we get cosine squared x is equal to 1 minus sine squared x. So if we replace the cosine here with 1 minus sine squared x, we'd actually end up with 1 minus sine squared x minus sine squared x, which would be 1 minus 2 sine squared x. And all that times 4. Well, that doesn't look like anything, so that's not really going to help us. Let's try then replacing the sine squared with 1 minus cosine squared. So if we take this and we substitute the sine squared, we get 4 cosine squared x minus 1 minus cosine squared x. Now, if we subtract a negative, it becomes positive. So we actually have 2 cosine squared x minus 1 times 4, which would simplify to be a.